Okay, welcome to section 3-4 video notes, graphing polynomial functions. Most of this should be a review of things that you've already had in part A. And we need to identify what a polynomial graph is going to look like. And this has been introduced a couple times before. The graph of a polynomial function is a smooth and continuous curve. So it can't have any breaks, holes, gaps, sharp turns, which are also called cusps, in them, otherwise it's not smooth and continuous. So let's also look at polynomials and the turning points, because those turning points can tell us something about the graph. So if we have a polynomial function p of x of degree n, then the graph of that function has at most n minus 1 turning points. So for example, if we have a third degree function, it can have at most 2 turning points. This also works in the opposite direction. If you're looking at a graph of a polynomial function and you see how many turning points that you have, you can figure out what the degree could be at the least. It's just helping us narrow it down. It may be higher than the value we calculate, but it has at least that many turning points. So if we take a look at a couple of graphs, you'll see the first graph. The beginning of this graph does not have an arrow, so this is not continuous. So right away we know this is not a polynomial, but let's take a look at some other features that makes this not a polynomial function. This has a sharp turn, and you can see that this is a piecewise function that has an absolute value piece. Absolute value functions are not polynomial functions. And we can also see that this has a gap in the data. So that's a third no-no, which makes this not a polynomial. Okay, let's take a look at our next graph. Well, if we look at it, it's continuous, has arrows on both ends of the graph. It also looks like it's a nice smooth curve, so this is smooth and continuous. So this doesn't have any telltale features that says it's not a polynomial, so we're going to conclude that it could be, that's therefore symbol, therefore it could be a polynomial. Okay, now let's take a look at the turning points. And turning points are where we change from an increasing to a decreasing part of the graph, or decreasing to increasing. So we have a turning point here, one down here, another one up here, and then our last one is right here. So we have 4 turning points. So if we use our equation that we have above, 4 is equal to n minus 1, so therefore n at a at